Hello friends. Today we are going to talk about something that I am sure is the dream of every IB physics student. How to score a 7 in IB physics exam. Let's face it, IB physics is a bit different from any other physics course that you will find in the high school level. So it definitely helps if a student is preparing and he or she has a mentor. Now, from a personal point of view, I can say that I am involved in tutoring IB physics online. So, if you're interested, definitely let me know in the email that I have provided in the description box, and we can take it forward from there. But nevertheless, over here in this video, I'm going to talk about certain points which I'm sure will help you in your preparation. And as the name of the channel suggests, it would provide an upthrust to your preparation of IB physics. Now, these are certain points which I think are necessary from my experience. But mind you, I do not have any magic wand by the help of which I can magically uplift your score. It's definitely dependent on your effort. But these are certain things that I feel you should have in mind, particularly when you're preparing. So let's begin. Uh, so, what are the things that are necessary for an IB physics students to score well or to score a 7 in IB physics? First of all, I would say that when you're doing your preparation, physics, in my opinion, should not be taken as such a subject where you have to just mark up equations. It's not so. In fact, if you are going through the equations and you feel like you have to memorize it, chances are that you have not understood the equation properly. If you understand it properly, it will stay in your head without you being without you requiring to memorize it. Trust me on this one. It really doesn't need any memorization. So what you need to do is that when you go through an equation, you really don't have to memorize it, but actually you have to understand it. So you really have to go deep into an equation. This is the first point that I feel should be there in the approach of any IB physics student, because I've seen that there are some students who feel that if you just go through the equations, you can apply them in the problems, and that's it. That's what's expected of them. Actually, it is far from the truth. The reason is any equation reveals much more if you are willing to really probe into it. Let me give you an example to prove my point. So let's say if you have all heard of principle of conservation of energy, and you know that in case of an object, when we consider its mechanical energy to be conserved, it's primarily made of its GP or gravitational potential energy and the kinetic energy or Ke. So if the total energy is conserved, considering of course there are no frictional forces present, then we can say that in any situation we can say that the total energy, let's say, which is E, that is constant. Now, what it automatically means is that over here, the change of GP, if an object encounters that, let's say when it's moving up, okay. So when it's moving up, it's definitely encountering a change of GP. It's also encountering a change of KE, KE meaning the kinetic energy. So the sum of these two would obviously be zero because the total energy is conserved. So what we can write is something like this. It's delta Gp plus delta Ke, that should be zero. Now, this is of course something which is very known to you. But what may not be that familiar is the interpretation of this equation. The interpretation can be in two ways. Either this, as you can understand, where delta Gp is equal to minus of delta K. Either this can be an interpretation of it, or certainly I can provide another interpretation of it, and that's something like this. Now, you can certainly tell me that what have I done different in the two steps? I've just multiplied with -1 on both sides, and that's how I've got this equation. But trust me, friends, it's much more than just -1 toggling between the two sides. If you carefully try to analyze this first step, where delta GP is written to be equal to minus delta KE, it actually means that the change of GPE in this case is positive and the change of KE is negative. So what you can understand from here is that over here we are referring to an object which is moving up, because of which its change of GPE is positive. You know that as it's moving up, it's losing kinetic energy and it's gaining potential energy. So that is what has been expressed in this equation. Now, if you try to look into the second equation, it's just the opposite, where there is reduction in GPE, and as a result, there is increase of Ke. Now, what is it that we understand from here? It's the same equation, but the the significance is something different. The reason is, you can understand that what this equation actually means is that the reduction in GP equals the increase of Ke and vice versa. That means the increase of Ke equals the reduction in GP. So although these are two equations with just a change of minus sign from left hand side to the right hand side and vice versa, but it's much more than that. So you can understand that just an analysis of this equation tells you about the case of vertical motion that we are studying, whether it's moving up, the object is moving up, or it's moving down. So careful analysis of the equation is needed to truly understand what it's telling us. It's actually the beautiful language of mathematics that is trying to reveal the setup, the situation, and we have to be trained enough to understand the language of mathematics. So I'm not, so it's that's why I said in the beginning that normally you have these small subtle points that are revealed to you in an equation, so you have to go deep into an equation, and for doing that sometimes it is necessary that you need a mentor. So I hope you find your mentor, and if you are able to do it on your own, that's absolutely great. I know there are many students who are able to do that, so that's absolutely great about them. But for others, yes, you might need one. So this is definitely one of the points that I thought is worth mentioning. Point number two is something that I'm sure some of you might laugh at, um, and some of you might think that this is not necessary, but this is what I will try to write. You know that in any exam of IB physics, you are given a data booklet. So, and I have seen that the students tend to depend on the data booklet as if it is their life. But and I understand that, because truly during an exam situation there's stress and there's a lot of things that's going through your mind. So yes, that adds to the comfort level of the students if the data booklet is there. But trust me on this one, actually if you are using data booklet, you are, in my opinion, going away from scoring well in the exam. And for that I would the reason I would say that is of 2 points. First of all, if you're going to the data booklet, if you're using the data booklet, you have to flip the pages multiple times during the exam, and your writing time effectively gets reduced. So obviously you are getting lesser time than, let's say, your peer who has lesser dependence on data booklet. Also, what I would say is that sometimes in hurry, when you're trying to copy an expression from the data booklet in your answer script, I've seen students make a mistake. So sometimes there are different physical expressions that you have to copy, and it's not always possible, keeping in mind the time crunch that the students face during an exam, to copy everything properly. That requires a very high level of attention, and it's possible that during exam students might falter from that. So this is my suggestion, everybody, that you should have your dependence of data booklet reduced as much as possible. In order to do that, you should try to practice as much as possible. Then you would automatically be able to recall the expressions that you need for solving a problem, so that eventually it's possible that you might not need the data booklet at all. And if you reach that stage of preparation, I would say, well done, really well done, because you are many steps ahead of your peer. I would certainly say that. I've seen some students, very small percentage of students uh, actually getting rid of the data booklet, but the ones who do that are able to achieve that with a lot of practice, and I'll try to explain how it is that you can do that in the later part of the video. But in general, going through a lesser dependence of data booklet, in my opinion, enhances your chance of scoring better in the IB physics exam. Now, moving on. The next point that I would say is I feel a very trivial point, but for some reason I can find that there are certain students who unfortunately don't do something as simple as this. So I'm going to write this point, and it's possible that you might find it is a bit silly, but I would still do it because of what I have experienced in my teaching career so far. Reading the question carefully, something as basic as that, is ignored for some reason by some students, which is extremely unfortunate. I've seen in multiple cases that, let's say, particularly in case of questions where you have multiple information given, a certain piece of information, a very small piece of information that is extremely necessary for solving the problem, is ignored because of not having this habit of reading the question properly. So I would sincerely suggest all of you to make this habit. So when you're reading through the question, make sure that you're reading each word properly. So for that also you need to go through a certain level of practice, and that's why I feel that it is extremely important that you start early. Now, I'll give you an example where it is that you might need it. So let's say if you're taking the case of an object which is moving up an inclined plane, and let's say it's given a very small word is mentioned that it's moving at constant speed. Now, as soon as you read that, it should strike in your mind that if the object, let's say it's a vehicle, it's moving up, the force that it's generating is exactly equaling all the other resistive forces, be it the component of gravity that is acting down, or if it is combined with friction, if that is present in the problem. So both these two forces should exactly equal the force that it is generating, so that on the vehicle there is no net force. So because of that, the power that it is generating would be equal to the resistive forces times the constant velocity with which it is moving. So many times I get this question: how is it that it is generating power when there is no net force? Although we know that power is force times velocity. The reason is, over here the power is needed to overcome the work or the energy that is lost in overcoming all the resistive forces. So here it is that you understand that the mentioning of the small word called constant speed, the vehicle is moving with constant speed, that word is key to solving this problem. So whenever reading the question, it is my earnest request that please make sure that you go through the question absolutely properly. So this is definitely a basic suggestion, but I feel it is necessary to mention over here. Number four, I think, is something which is a bit cliched, I would say, um, because I'm sure you've heard this many a times, but I'm still going to mention it. So I'm going to say this about the need of practice, and why it is that it is absolutely essential for you to go through it. Now, it's something like this that whenever you're practicing, it's actually it goes on like this. Our brain, your best friend during an exam and your worst enemy at the same time during an exam. This is kind of interesting, because how is it that we can have the same thing behaving as a friend and as well as an enemy? Well, you okay? Let me explain it with a physics concept. You are aware of the dual nature of matter. And you are also aware about, I'm sure, Schrodinger's cat, which is at the same time dead and alive, two completely different states. So in that regard, your brain can also be something like that, having the features of two completely different, different versions, I would say. So the way our brain works is obviously, if you are able to reinforce concepts after multiple practice, then it becomes easier for you to recall them once you need them during an exam. So practice is there cannot be any substitute for practice. So written practice makes a student perfect. I'm sure you have heard it about how practice makes a man perfect. But yes, in general, any student, for him or her, practice is essential. It's absolutely something which you cannot do away with. It's absolutely essential. So and of course, when you're doing it, when you're practicing it, you need to practice it, I would say, vectorially. The reason I say that is because I feel practice needs a direction. So unless you are smart enough, unless you're practicing properly in the proper direction, I don't think that's hardly going to make any difference. So certainly practice is necessary in the proper direction to help you achieve this goal. Now over here, I would definitely try to mention something which I feel is much more than just an expression in physics. You are aware about Newton's second law, about how about one of the expressions of Newton's second law, about how force is mass times acceleration. So what I can say is that when you're practicing, you're actually causing a change of state, whatever state you are in. An acceleration denotes the change of state, the rate at which your change of state is happening. So Newton's second law tells us that it's the ratio of the force, meaning the effort that you give, and the inertia that you have, that truly determines the rate at which you are progressing, you are changing your state. So certainly all of us, all human beings, have our inherent inertia of not doing things in time, of not of keeping things postponed till the very last moment. That you can understand, everybody is definitely not going to help in boosting up the acceleration. So proper force and making sure that you have overcome the inertia is going to be absolutely central in making you achieve that score in IB physics. So I feel these are certain points that are to be mentioned. Of course, there are detailed analysis that is necessary for other points, I would say, but these are the basics. I didn't go into how you should practice for each of the papers separately, paper 1, 2 and 3. I can do that in a later video, but I think I did not include it over here because it would become very long. I also did not mention about the IA, which is a very, very important component. So all those, I think I can do it in a different video, but for these are just the very, very bare minima that you have to ensure should be there in your preparation to actually get that upthrust in your preparation. So that's what I feel are necessary for scoring good in your IB physics exam. So that's it for today, everybody. Thank you for watching and thank you for your time. I hope these points will help you in getting a better score in IB physics, and for all your comments and suggestions, definitely I'm looking forward to it. So let me know what you feel about the video, and let me know if you want to if you want me to add anything else. Thank you for your time and all the best for your preparations. Thank you, everybody.